Okay, cool. Awesome. All right. So, welcome, guys. Welcome to Introduction to Site Reliability Engineering. My name is Raghav, and today I want to give you some more insights into the world of SRE and infrastructure from my experiences. And I also hope to inspire you guys. If you're not already in SRE or into DevOps, I hope to inspire you to take more steps towards SRE to show you how interesting this whole world really is. Cool. Let's begin then. A little bit about me. So it turns out that it was surprisingly difficult for me to summarize my entire career in just one PowerPoint slide, but here it is. I'm an SRE by profession. I also love writing open source developer tools generally, and a little bit of content creation here and there. So I'm really, in general, really passionate about distributed systems, dev productivity, and educating, like just my experience not to do. That's also very important in the world of reliability. Okay. This is the outline of what we're going to be covering today. We're going to start with a very broad overview of what SRE is, who is an SRE, and what the world of infra looks like. We then move on to what exactly do SREs do, and promises, which are basically the bane of all SREs problems and their existence. That's where everything originates from for them. We then move on to infrastructure automation, the mindset behind SRE culture, and then finally, how do I become one? Like, what does it take to just make a move, regardless of your background, regardless of whether you come from a software engineering or a QA background? How do you make a move to an SRE, right? All right, then let's begin. So, who's an SRE? That's our first question. I have a simple question for you guys, and some of you are already SREs in DevOps. I think we do answer this. If you've ever been a developer or you've ever been a QA and you need some infrastructure, maybe you need a server or like a database cluster or a Kafka queue just to get some work done, maybe an experiment or a test environment, right? In your org, who do you generally go to? Like, do you go to a person? Do you file a ticket? Do you go to a team and just like, or do you shoot a message on Slack? What do you do if you need a server? Or like, is AWS in your own control and you just spin up one? You can, if you'd like to answer, you can answer on the chat, or you can also unmute and let us know. Okay, ask it in the dev meeting. All right. So what you mean is generally somebody in your entire developer team would know how to manage this infrastructure, and then they just spin one up for you and just give it to you. They'll give a bunch of SSH credentials to you, so you can just log in the machine and do your job. All right. Okay, cool. Yeah, so essentially, that is what the whole idea is behind a DevOps team, right? In different companies, you would know these teams by different names. Maybe in some company, they call it platform engineering. In some, they'd call it an SRE. Or in some companies, it would be a DevOps team, right? But the idea of an infrastructure team is a bunch of people who specialize in operating the infrastructure. And they'll give this infrastructure to you whenever you want to do something, and they'll manage all the underlying infra. So whether it's just an experiment or a dev environment or even the infrastructure running in production, this is normally the team, or maybe there are multiple teams who are managing all this infrastructure for you, right? So coming back to our main question, who is an SRE? The term itself, site reliability engineer, and the culture both originated at Google, right? This was when Google started to face problems when their DevOps team, when the teams that were simply supposed to run operations scale. Take a very simple example that every time a developer needed a new machine or a new piece of infrastructure to get some job done, they would go ask in a dev team or file a ticket or just go to some DevOps and they'd ask this infrastructure version. And so you can imagine how frustrating this process gets over time, because you as a developer now have to just ask it, shoot a message, and then maybe somebody looks at it, maybe nobody looks at it. You have to remind, you have to wait for the infrastructure. On the other side, there's a DevOps team which may be overloaded with such requests and is simply not able to serve your requests on time. So there's a little bit of friction on both sides, and neither of them are happy, right? And that was the origin of SRE, when a bunch of software engineers were tasked to do these operations. And they were told, do it the way you do software engineering, the way you like to automate everything, automate yourself out of this job, right? And that's essentially where the whole of SRE concept and the culture was born. So what's the mantra? The mantra is very simple: automate all the operations. An SRE team is essentially a bunch of software engineers who are automating all the operational tasks of an infrastructure. So can you guys recognize all these logos or some of these logos? If yes, you can type it in the chat. Okay. Can you name them? Okay. So the idea behind all these tools is some or the other way. Yep. GitLab, Docker, Jenkins. Right. I'm surprised that you also recognize Argo, because very few people recognize Argo as a tool. Yep. So the idea behind all these tools, and of course, there's a lot more tools in the cloud native world, but these tools enable you to do more automation in some way or the other, right? And that's exactly why these tools exist. And there's also one more point to this, that automation doesn't always necessarily mean that you're writing code, right? You may not be writing an application to automate something there, because chances are that the problem that you're trying to automate, people have already solved that problem over and over, and there's a very mature tool out there available just for you to solve that problem. So you won't necessarily be writing code, but instead just adopting a tool, putting it in, there you go, making a bunch of stuff. So that is the mindset behind SRE: automate all the operations. And now we'll dive into what exactly do SREs do, right? So before we move forward, can anyone tell me what is their understanding of a promise in production? Okay, high reliability and availability. That is true, actually. A promise, essentially what it is, it's the contract that you give to your end customers, your end users, that if running a system in production, this is the contract that I give you. This is the kind of service I'm going to give you for this much time. And if I breach this contract, I will have consequences, right? And I will make it up to you in some or the other form. That is a very, very abstract term, a very, very abstract definition of promise. So let's look at a more concrete term for promises, right? In the world of reliability, there's three very important terms: SLIs, SLOs, and SLAs, right? You guys might have heard of SLA already, because regardless of whether you're a vendor or whether you're somebody who's a potential customer, people might have talked to you about SLAs, like, hey, this is an SLA we provide, and of course, like, if we do not deliver on this, we'll reimburse you your money and stuff like that, right? So what is an SLI? First of all, let's define that, right? SLI stands for service level indicator, and it's a very, very fancy term for a metric that measures a specific aspect of systems performance, right? So examples being latency and uptime. So can anyone tell me what latency is and what uptime is? Yep, yep, exactly. That's correct. Yeah. So the idea behind latency is how much time does my system take to respond to a request that was initiated by my user, right? And if it takes too long, if it takes long enough that the human notices that oh god, this website is slow, they'll just lose their attention, and I will lose a customer or a potential customer, right? And uptime is the amount of time over any particular period, let's say over a month, right? The amount of time for which my service remains available and responds to you, right? Imagine if you try to open up Instagram and Instagram just doesn't open, or you try to post a picture, but Instagram just returns an sorry, I can't let you post the picture, right? That's Instagram being down and not demonstrating so much uptime. So that's the idea behind latency and uptime. These are very, very simple and very common examples of service level indicators, right? Up next, we've got service level objective or SLO, right? The idea behind SLO is it's an internal target for any SLI. Okay, so if I'm saying uptime, okay, and I'm measuring the uptime over the last 1 week, let's say, measuring is good. I can see a graph and I can see some trends, but what do I do with that measurement, right? I should have a goal in mind that, okay, let's say my uptime is 99% and I want to keep it at 99% for the full month, which means if I'm running a service, this service should remain up and available to our end customers for 99% of my month. That's simply what it means. The important aspect here is an SLO is an internal target. What that means is you don't expose this SLO to your end customers, right? Rather, it's an ambitious target that you and your team want to always achieve. Okay. And the important bit is that SLO is your your line of alert. Like if you're breaching an SLO, that means it's a cause for concern. You should drop everything, try and fix your system so that it no longer is degrading, and so it doesn't breach any of the SLAs, right? And finally, we come to SLAs, which is a service level agreement. This is a legally binding contract which you give to your end customers. So if you're telling your end customer that, hey, my service is going to be available for 99% of the time for the entire month, then that's a promise to you that I'm giving. And if I do not deliver on that promise, I will have to compensate you, right? And these breaching an SLA most likely will have legal consequences, financial consequences, and of course, brand reputation and all that, right? And for example, Google's Cloud Spanner database has an uptime SLA of 99.999. That's like 5 nines of reliability, 5 nines of uptime, right? So just imagine like what kind of engineering goes into making sure that that's how highly available this service is going to be. Okay, so quick question now. What do you think should be a stricter value? And so, what I mean by this question is, if let's say I have a Hello World service and I want to set the SLO and SLA target for that for uptime, okay, and I say that the SLA that I'm giving to my end customers is 99%. So, should my SLO be higher than 99%, or should it be lower than 99% for uptime? Mm-hmm. Any other responses? Okay. Um, for uptime, uh, so the general rule is the SLO should always be stricter than the SLA, right? Because remember, the main purpose of an SLO is the moment we are breaching an SLO, that time we should be alerted that our system is degrading. We need to do something to make sure that it doesn't continue to eventually breach our SLA, right? So now think about it this way. If my I do not want that my system reaches below 99%. Okay. So that means I should be alerted before I'm even approaching 99%, which means my SLO for uptime should be higher. And we'll see a quick example of this. Yeah. So here's a simple graph showing us the uptime, right? We can see that we have a 99.9% SLA, okay? And SLO is higher. And the green line is the uptime. So what we see is we start with a very good uptime. It's around 100%, right? But then it starts to fall. And it falls very, like in a very steep manner, right? And first, it should breach the SLO. The moment it breaches the SLO, everyone should get alerted that like just and the system, otherwise we're going to breach our SLAs, right? Unfortunately, in this situation, the system continued to degrade until we also breached our SLA. At this point, we are screwed, right? Of course. But then we tried to do something, fixed our system, and eventually we recovered from our SLA and then also recovered onto and above our SLO. Okay. So this was a full story of how our system began to degrade, probably because of some reason, and we breached our SLA, but eventually recovered. And of course, because we also breached our SLA, there were some consequences. Maybe we had to reimburse some money or whatever else, right? But in general, the rule is SLO is always stricter than SLA because its only job is to alert us before we are about to breach SLA. That's all. Okay, so this is a very simple calculation question. Can anybody tell me the answer to this? A lot lesser than a day. The hint is it's a simple percentage calculation. Think about I'm saying okay, 99 point or just to simplify, 99% of my entire month, right? So how much is the downtime? That's 1% for the entire month. So same way. Yep. That's right. Yeah, cool. So let's see how we arrived at those numbers, right? Okay, so we have the uptime of 99.95%. The maximum downtime that we can take in a month is 0.05%, right? Now, just a quick calculation. The number of minutes that we have in a month is a total of 43,200, assuming 30 days in a month. And you take 0.05% of that, and that's just 21.6 minutes. So if my service has an uptime SLA of 99.95%, then I can only afford a downtime of 21.6 minutes. And imagine that, like 21 minutes, like if there is an incident that I'm involved in, I will take more than 21 minutes just to fix and understand what is going on, right? So that's, and now imagine that Google Cloud Spanner has a 5 nines of availability. So that's kind of how of engineering, the level of automation and reliability that goes into building something like Spanner is. Is this calculation clear to everyone? Anyone who's still confused with it? Okay, cool. So here's another question for you then. What do you do if you've breached your uptime SLO for the month? And SLO, remember, it's an SLO. You haven't yet breached your SLA. Okay. Forgot to divide. That's fine. But you got there. You got there. So the question here is, what happens if you breach your SLO for the month, right? You haven't yet breached your SLA, but you have breached your SLO, and now you're in the danger zone. Like if you don't stabilize the system, you will eventually breach your SLA. So what all do you think? And 2, 3 more weeks to go before the month ends. It is not yet a cause for alerting customers because, of course, if you breach the SLA, then yes, the customers need to be informed. But the point is, until the SLA is breached, this is purely an internal problem. It's like, why are you telling me about your internal problem? You go ahead and stabilize the system, fix it, or whatever. But I don't need to know it right now. Yes, okay. That's a good goal to increase your availability for the rest of the month. But increasing means that at best you can remain, let's suppose 99% and your OSLO, let's say at 98%. At best you can continue to maintain 98%. You can't go back up because you've already lost that much time in the month. So at best you're maintaining. Okay. So one of the very, very important answers to this question, I'm not saying that's the only answer, but one of the most important things that you do is a complete. Okay. The idea behind the change, you no longer push any code to your system. You no longer push any infrastructure changes to your system, right? Whatever features, bug fixes you were working on, optimizations that you were working on, or any firewall configurations you were working on, does not matter. For the rest of the month, you do not push any of those things. Instead, you just focus on stabilizing the system and make sure that the system continues to stay stable, right? What that means is probably just add a few more servers just in case, like there's some extra traffic, over provision some of the infrastructure, and do not push anything because of which there might be a potential downtime. I mean, like, we've all been in that situation where we pushed some code and that broke the entire service, right? I have been in one, I know that. So that's why we do all sorts of code freezes and all sorts of infrastructure change freezes, because we also don't want that somebody was trying to optimize something in the network configuration and now suddenly they've blocked all traffic to the service. Once again, even though the service was running, there's no traffic that is able to reach it. Now you have more downtime and now you've reached your SLA. You don't want to do that. That's why a complete change freeze is the absolute requirement once you have breached your SLO for the month. Okay. And now for the SRE's jobs, that is running operations like an engineer, right? And what that means is automate as much of the infrastructure operations as possible. That's the SRE methodology. So the number one that you'll in the SRE world is toil, right? Toil is any kind of task which is repetitive. You find yourself doing it over and over and over again, and you kind of get bored and you realize that at some point you've probably made a human error because you were so bored of doing that, and because of that there was some other outage, right? So toil is a classic example of something that can be very easily automated, if not easily, but there's a huge value in automating that kind of a task, right? And we have some examples over here. If you're a DevOps engineer, then you know that you've often checked firewalls for misconfiguration. If you work with AWS, you've checked security groups. Time and again, you have to set up these security groups, and this is a very big effort, right? Or maybe taking a bunch of data back. You have a huge MySQL cluster, and you're supposed to take backup. So what do? Do you go there like every month and take a periodic backup yourself? Like, you just trigger a tool, or do you have some sort of automation in place for that too, right? If you have an automation, then you're transitioning towards an SRE mindset, which is automate away these kind of operations. Otherwise, if you keep doing it over and over, eventually you'll make a human error, not intentionally, but by mistake. And that might cause, the thing to just blow up. And that's happened. Okay. So yeah, uh, going back to our earlier example of setting up infrastructure based on somebody's requests, you need some infra, you go to a team, you say, hey guys, please give me a server, and then this team does the job and gives it back to you, right? This whole process can be automated. And yeah, so the number one thing about automating the infrastructure is eliminate all toil. Up next, one of my favorites, what I like to say is don't just provide, but enable. And what that means is, if somebody comes to you asking for infrastructure, you're the SRE, you're the DevOps engineer, right? Uh, don't just process the ticket, create new infra, and give it back to them. If you keep doing this, that's just toil once again. Instead, focus on creating better interfaces, better platforms for your users, for your customers, right? In this case, if I'm an SRE, my customers a developer who wants some machines, who wants some infrastructure, right? Rather than just processing their tickets all the time, I would focus on setting up some sort of a platform so that it becomes a self-serving thing for them, right? The developer comes onto that platform, they can just uh, click, do a bunch of point and click, and they get themselves a MySQL cluster or an EC2 machine where they can do their job. And once they don't need it, they can also destroy it. Or if they need it in production, they can promote it to production. All these things, a platform lets them do this, right? What is the main advantage of this? The main advantage of this is you free up yourself from this kind of repetitive task, right? And more importantly, you are building a system that is self-evolving. Okay, in this system, people are enabled to solve their problems on their own. They take lesser of your bandwidth, and they're able to. Okay, it cuts down on everyone's time. Good for productivity. It eliminates a lot of scope for downtimes, because now there is no scope in error. Everything is codified and just being done by a computer. So yeah, platforms are always a good way to go forward, to enable other people to just solve their problems on their own rather than involving you. Okay, you need to educate other people through documentations and workshop. And finally, automate the enforcement of a lot of best practices, right? A clear examples right here, like GitHub checks. If you've at some point just been to a GitHub repo and set up some sonar cube or some checks and block the merge, so that unless these checks pass, the pull request cannot be merged, right? That's an SRE mindset. That's some sort of automation that you've already implemented, so that people who are reviewing pull requests don't have to go through that. It's already automated for them. All right. So now we are in the last phase where we talk about how do I become an SRE, right? And even if you don't aspire to become a full-fledged SRE, and you simply want to see how to get more involved in this field, right? This is the section. Okay. So here's a small Venn diagram representation of what kind of skills an SRE generally has, right? And before we go, can anyone tell me what exactly are soft skills? Because obviously we all know what programming is and what system administration is, but what are soft skills? Good skills, communication. Yep. Yep. Okay. Yeah. So that's exactly what soft skills are. The idea is time management. Yes, that's a big one. The idea is, as an SRE, you will not just be sitting on your laptop and coding, or doing automation or building infrastructure all the time. In fact, you spend a significant amount of your time dealing with other developers, uh, other sorts of engineers, engineering managers, product managers. Why? Because every time there's a product or a service that's being built or evolved, right, you come in there, you step in there because you have to speak from the reliability point of view. Okay, you understand reliability like nobody else does, and so if there's a design discussion, a technical design discussion of the architecture or of some code repository, right, you have to be present and you have to push for more reliable architectural practices in them, right? And that's not going to happen by default, often because for example, a product manager would have their own priorities. Their priorities would be ship as many features as we possibly can, and that's great, right? A developer would be more prone towards, okay, we also need a really good code structure because otherwise it's not manageable and it's a headache for me. That's fair. Yeah. EM would have a different priorities that, okay, let's try and increase the productivity as much as possible. So why do we need to care about reliability when we can build more features and stuff like that, right? Everyone comes with their own priorities. You come with the priority of having more reliability into that, right? And when that happens, it is very easy to have some friction, to have some conflict. Do not be afraid of that, right? That's when your soft skills really shine. You have to talk to these people, sometimes juniors, sometimes they might even be your seniors, but you have to push for more reliability also. Every time they're saying, no, we simply don't have bandwidth for including what you're suggesting, you tell them why reliability is important, why we have promises given to our customers, and why they matter, right? Because if all these features are useless if we breach our SLA and we have to ultimately just shell out a lot of money back to our customers, all the money we earned kind of does not make sense anymore, right? So that's where soft skills come into play. And I would argue that soft skills is mandatory for SREs, right? The other two, you can have like a balance. You may be really good at programming and okay-ish at system administration, or the other way around, which is fine. But soft skills is an absolute must, right? So it's very unlike other technical roles. Yeah, and lastly, this a small GIF that I wanted to show here. What that means is, in the world of SRE, theory is not enough, right? And what that means is, it doesn't matter if you read books, if you see a bunch of documents, that's not enough to get you into an SRE world. Rather, you have to dive into the deep, right? Because unlike software engineering, where you could potentially learn a lot of engineering skills just on your laptop, right? The world of SRE involves real world infrastructure, which costs a lot of money, and real world production traffic, right? And all these things you cannot replicate them on your local laptop. You have to be exposed to a production environment to be able to work on these things. Yeah, and another important thing is that there is no formal education out there for SRE, right? Kind of like how computer science is there with a lot of other streams. But since there's no formal education and companies recognize this, right? Chances are a lot of companies will be willing to just give you a chance, even if you're upfront with them. Okay, I come from a software background, or I come from data science or QA background. I don't know anything about infrastructure, but I'd like to learn on the job and do it, right? Chances are very good that people will just give you plenty of opportunities to do that, because people want to hire SREs, they want to hire DevOps engineers, but they also recognize the fact that we cannot teach this in college, and we have to teach this to them on the job. So just because you don't come from an infrastructure background doesn't mean that it's going to be super hard for you to break through, right? Breaking through would be easy. It would be uncomfortable, yes, because you are in a totally new territory, but it'll still be fun. Yeah, here's a bunch of things that SREs normally do. There may be a lot more. I actually initially started out with a list of some 20 things, but you're supposed to, trim down the text on a slide. So I came to like top 6 points that I could think of, right? You might already be doing some of these things. If you are, that's great. And if you're not, you can start doing them to get more involved in SRE. And if you are doing them, start doing them from a reliability point of view as well, right? Does this make my application more reliable? Does it increase the uptime, or does it guarantee a certain amount of uptime? or does it negatively impact my latency in some way, right? That's an SRE way of thinking. All right, how are we on time? Okay, so it's time for us to wrap up, and there are three things that I really want you to take away from this entire talk today. The first is, who is an SRE? It's essentially just somebody with a software engineering mindset who is tasked with operating the entire infrastructure, right? Doing all the operations. You're supposed to be lazy. Think like a software engineer. Automate as much as as much as possible. Create platforms and enable other people to do their own job instead of relying on you. Okay. You, as an SRE, always help to define and keep promises in production. We talked about SLIs, SLOs, SLAs. We don't just enforce them. We, as SREs, also participate in setting them up, right? For SLAs, we talk to legal department, we talk to product managers, marketing, a lot of different departments. SREs are involved in conversations with those. And finally, the best way to become an SRE is to just dive right in. People will give you opportunities, so just go for it, right? I will also, I think I should be able to share this slide deck. There's a bunch of links. There are some really good links. Google has written an book about their entire culture. I highly recommend it, that you go through it. At least some of the parts around automation and SLOs, very helpful, even if you're not totally transitioning into an SRE role, right? There are some really good examples of SLAs that big companies have published, right? And like, if you just go to them, these are legal documents published for the whole world to see that, hey, this is what we're providing to you as a service. These are our guarantees. If you breach them, we give you your money back. All these things are like publicly available, right? That's how serious SLAs are. And that's how seriously a company has to take, an SRE has to take them. And there's LinkedIn has also come up with its own school of SRE, which teaches a lot about the SRE culture. Okay, cool then. I would love to have, like, if there are any questions, please feel free to ask. You can ask on, there's a Q&A section on this. You can also ask on chat, or you can, if you'd like to, feel free. Okay, so I think it's safe for me to assume that there are no questions. Okay. Let's see. What skills do SRE need to prioritize over others? Really good question. So the thing is, you can, if we go back to our little Venn diagram, right? Soft skills, of course, a very high priority. Out of programming and system administration, you can choose to prioritize whatever you like most, right? You don't need to be a master of both of them. I don't recommend that, because like, you're kind of diverting your focus. One thing and very good at the other thing. Whichever you like more, you can just focus more on that. For example, for me, I am more of a sysadmin guy, right? I really love Linux internals and cloud operating, AWS and all that. I love it more than writing Python or Golang, for example. The idea behind this is, all the companies, they understand that SREs come from different kinds of backgrounds, right? If you're low on programming but high on system internals, you're still very valuable, and they understand that you can learn more programming on the job. And other way around, of course, you can still learn more system internals. But in general, what I've seen is, in SRE interviews, more preference is given to system administration, like Linux skills, or talking about infrastructure architecture, like how would you design a microservice? How would you design 1,000 metrics per second into our infrastructure, right? A system design question. So that's what I've generally seen. So if your aim is to, ace big interviews in big companies like Bang or Booking or any of these companies or Uber or something, right? Chances are system administration is going to help you a lot more than programming. But of course, these same companies often ask you lead code style questions. So I wouldn't say that's strictly a software engineering skill. It's more of like if you've practiced a lot on lead code and you've done a bunch of algorithms and data structures, then you'll be able to ace that interview also. But yeah, in general, system administration would be my recommendation to you also. Okay. Um, I believe there are no other questions. In that case, we are good to wrap up and have a nice day, guys. Have a nice weekend, actually. And please feel free to reach out to me for any feedback or if you want to just generally chit chat. I'm available on I'm available on LinkedIn and GitHub. So, and have a great weekend. I hope you were able to take back some insights with you. Sure, Gesh. Cheers.